First of all, thank you very much for inviting us today. Very exciting. So my name is Tyson Hosmer. I'm an associate researcher with Zaha Hadid Architects, where I lead the ABPS research group together with Patrick Schumacher, and I'm also a senior teaching fellow here at the Bartlett as well. So today I'll be presenting a software framework we've been developing at Zaha Hadid, focused on simulating human social behavior and interaction. As you kind of commented, I mean, this is essentially like 2.5 years of work kind of in a poster. So basically, our research and our software in general is kind of built on the hypothesis that human behavior is interrelated with architectural space, and that relationship can be simulated and measured to predict the social performance of architectural spaces. There's kind of 3 main parts to our work. So we're building a cognitive agent-based model to simulate and analyze human behavior and social patterns in relation to architectural features, as well as calibrating that model using real-world data, and building a generative design framework trained using that simulation model as well as other metrics. So this is a kind of overall view of that work that we're doing. Our simulation model must be able to simulate relatively accurate collective human social behavior, be lightweight and capable of handling larger crowds, parametrically controllable, as well as generalizable and extendable to other architectural environments and scenarios. So typically in the building industry, we see crowd modeling used focused primarily on identifying circulation problems. We're focused much more on social interaction and behavior, specifically in the workplace domain. This is, of course, an image of what we don't want. So people completely separated, expecting to work in the exact same way and with no place to collaborate. So workplaces today are much more like dynamic ecosystems. They look a bit more like this. So they're very diverse, they're agile, and they're adaptive, enabling dynamic collaborative processes to take place. So some of our main goals are to increase casual social encounters, as well as effective unplanned collaboration, increase visual connectivity and flexibility of our spaces, as well as make our spaces communicate more clearly with the users. So our model is built on 3 main parts: the cognitive agent, the environment, as well as the data that goes in and out of that model. The cognitive agent. So basically our agent is composed of 6 main groups of internal properties, including its affiliations, its internal state motivational variables. So these are dynamically changing variables such as motivation to do work or to have a kind of social interaction. This changes based on what the agents are doing at any given time. They have a 3D perception, an efficient pathfinding, kind of AI decision-making process, as well as a kind of adaptive memory. So here you see a kind of visual representation of their vision. So each agent autonomously has its own vision encapsulated in this environment. They can see which agents are within their view 3-dimensionally, as well as objects they can interact with, and then assess those objects and agents and their affiliation to them. So here you can kind of see kind of 3-dimensional heat map being produced through the collective crowd. So this is a collective vision map understanding the areas of the scene that are seen most and the least. As one assessment. So basically, in assessing our design decision-making framework, early on, we decided upon a utility-based framework based on its ability to be nonlinear, generalizable, as well as scalable and efficient. Essentially, our decision-making process, each agent takes autonomous decisions to conduct each action based on the state of the environment, its internal state, its internal parameters, as well as weighing considerations surrounding potential actions to take. So you see here, each agent, depending on its type, has a set of potential actions, which are essentially a sequence or a chaining of smaller actions, which can be interrupted or paused or carried out based on the changing conditions of the environment. Decision-making, basically, as you can see here, is basically a series of considerations, such as the distance to an object or the time of day related to the action that the agent is considering to do. So decision-making, you can see here, for example, how thirsty is an agent, or how close is it to a kitchen, or is that kitchen visibly occupied by other agents that particular agent is socially connected to. Next, the environment. So the environment is essentially our design space. Of course, it contains the agents themselves, destinations, which are kind of interactable objects, zones of activity, as well as events. And events are both scheduled, things like meetings, as well as unscheduled. So you can see here some examples of destinations. They're basically design features such as desks or tables or other interactable objects in a workplace. which the agents can interact and get information from and give information to. So here, for example, there are scheduled events. So we have a kind of input of potential meetings for the day, and agents that are on a particular team would then be instructed to go to a meeting at that time. And then we have spontaneous events. So these are unscheduled events such as encounters where people cross paths with each other, and we try to map those across our scene. Or events that are social events such as collaborations or conversations. So for example, a conversation could happen between 2 or more agents and could occur anywhere, like a standing area or anything. Whereas collaborations occur between agents which are only nearby or around supporting destinations. So things that support collaboration, and we want to increase that in our designs. So finally, data, input and output. So input data, we can characterize the types of our agents and kind of characterize the kind of heterogeneous nature of our crowd, let's say, based on an office culture we're designing for. So the kind of distribution and occupancy of different types. And then in terms of output data, we have spatially situated as well as quantifiable data. So we have, for example, asset data such as desk to area ratios and things to do with the design. We have quantities such as the number of conversations or collaborations or encounters, the percentages of time spent doing various actions collectively over the crowd. And then finally, spatially situated data, which is mapped over the space. So things like the encounters and conversations and collaborations, where did they occur? And how can that be mapped to understand areas of highest activity? So here you see essentially data points which are dropped by the agents throughout the simulations. And these data points record where and when and what action was taking place in different areas. Using that, we can compose these kind of data maps to pull out different pieces of information. Where do people walk the most? Where do people have the most conversations? Where do they have different types of interactions? We also map things like sound. And then finally, we have historical and live data, which is collected over time, mapping direct quantities. So things like the percentage of time spent walking in a particular design versus doing other activities. We can also identify, for example, destinations that are utilized the least or the most to try to improve the design, let's say. So finally, I don't have much time for this, but empirical data integration, just briefly, we're trying to calibrate our simulation model using empirical data input. So we're looking at things like occupancy sensing within our own office, surrounding pairwise and individual behavior in relation to architectural features. We're looking at employee surveys as a way of quantifying different actions. How long do they occur, with who, and where, things like this. And then finally, social network analysis through Skype for Business. We're looking at social networks within our own office and others' offices, and trying to then connect that back to our input into our crowd simulations. So finally, the design process. Basically, this is an iterative data-driven process. So here you see a kind of collective crowd of about 2,000 agents run over a very large floor plate for a concept design that we did recently. From this, we essentially are testing organizational strategies, things like the arrangement of design features, simulating and comparing options, identifying areas to reconfigure, and improving the social performance of those spaces through this kind of iterative process. So finally, I'll just leave you with a video of our generative design tool, which we've also been developing, and how it operates together with the simulation tool. So basically, this generative design tool allows the user to select workplace assets that they want to arrange and reconfigure within an office space, as well as setting design goals, such as the percentage of private working desks versus collaborative spaces, meeting spaces, degrees of connectivity, and different kinds of other goals that they want to achieve. The tool automates the generation of large quantities of workplace designs and hooks into our analytics tools, which we're now trying to train using various machine learning operations. So here you see the simulation process running over the generated design. And then you'll see a series of maps. So we have kind of historical data of the overall crowd, things like where did they walk the most, talk the most, where did they collaborate the most, here collective vision, where are the most encounters occurring, here is a sound map locating areas with the most sound being projected. So we try to keep that in the right locations, and then daylighting, kind of a primitive daylighting map. And then finally, you'll just see quickly a kind of first-person experiential view. So this is all in VR, so you can actually, in real time, see the generated design and experience it from a first-person point of view. And that's it. Thank you very much.